Hello everyone, this is Roy PCB, your trusted PCB partner. Today we will introduce double layer PCB ground plane design, the advantages of the bottom layer, and via optimization. In double layer PCB design, a stable and reliable ground plane is the cornerstone of a successful circuit. Many seemingly tricky noise interference and system instability issues often stem from improper ground layout. Mastering the correct ground plane design methods, especially using the bottom layer as the overall ground plane, is key to improving circuit performance. The importance of using the bottom layer as the overall ground plane. In double layer boards, the most recommended design strategy is to use the entire bottom layer as a complete large area ground plane. This is not an arbitrary choice, but one based on three core advantages it brings. First, let's take a look at our circuit. We've also applied copper core on the top layer, which is also ground. However, since there are many components on the top layer, the ground in key areas is often fragmented and disconnected, and in some places it's even impossible to apply copper core. Now let's look at the bottom layer. You'll see that there are very few traces, only a handful, and they're very short. So the entire bottom layer maintains a complete ground plane, and this is the current state of the bottom layer's ground plane. These are the battery connection wires, and there are no other components on this side, so they won't cause any fragmentation of the ground plane. The vast majority of components are in this area, so it's important to ensure the integrity of the ground plane here. Now let's continue with the three core advantages we mentioned. First, it provides extremely low return path impedance. All signal currents in a circuit require a return path to flow back to their origin. If the ground wire is laid out as a thin, elongated wire like an ordinary signal line, its impedance will be very high, especially for high-frequency signals. This can lead to voltage drops, ground bounce, and signal distortion. A complete ground plane, on the other hand, is like an infinitely wide highway, providing the shortest and most direct return path for all currents, with extremely low impedance, thereby ensuring signal integrity. Just like on this circuit board, for all the components on the top layer, whenever any component needs to return a signal to ground, it can easily find a nearby ground plane and return through the large ground plane through the ground. Second, it provides excellent electromagnetic shielding. A continuous ground plane acts like a huge metal shield. It can effectively isolate the signals on the top layer from external electromagnetic interference, while also containing the electromagnetic fields generated by the top layer signals to prevent them from radiating outward, thereby reducing the EMI issues of the circuit board. Just like in our case, the bottom layer basically covers all component areas with the ground plane, so any electromagnetic signals coming from this side will be shielded by the copper-clad plane on the bottom layer. And much of the radiation that would otherwise go outward will also be absorbed by the ground plane, significantly reducing the circuit's radiation. Assisting with heat dissipation. A large area of copper foil is an excellent conductor, not only of electricity, but also of heat. For heat-generating components on the circuit, such as boost converters and high-power ICs, the ground plane can serve as a natural heat sink, evenly conducting heat away and helping the components dissipate heat. For example, in our design, there are many such cases. This one here is a power device and its ground is connected to the ground plane. I've also added some vias nearby to conduct heat from the top layer down to the bottom. This component also has many vias placed under its three-phase board and around it to conduct heat away. How can we effectively connect the top layer ground to the ground plane using vias? Since the bottom layer is the ground plane, how do the ground pins of the top layer components connect to it? The answer is to use vias. Vias act as bridges connecting the top and bottom layers, and their use directly affects the effectiveness of the ground plane. There are two core principles to follow when optimizing vias. The first is the principle of proximity. For every pin that needs to be grounded, a dedicated ground via should be placed right next to it. The principle for current flow is to minimize the loop area. The closer the via is to the pin, the shorter the path for current to flow from the component to the ground plane, resulting in a smaller loop. As we can clearly observe here, this practice is not exclusively for integrated circuits or ICs, but rather, whenever these particular capacitors possess dedicated ground pins, I consistently make it a point to strategically place several vias. This meticulous placement serves to effectively connect the uppermost and lowermost ground layers, thereby ensuring the provision of maximum possible current conduction and establishing the absolute shortest electrical path available. Next is the principle of ample usage. The more, the better. Don't be stingy with them. For ground vias that need to carry larger currents, you should place many vias in rows and columns in the open areas and along the edges of the power board. This technique is called ground stitching, which can further reduce ground impedance and ensure that the ground plane shift is minimized to enhance shielding effectiveness. From this circuit, we can also see that it's not just the ground plane, other signals as well. In order to increase the current capacity, I also added many vias. For example, these are all enhancements. This is a ground plane, and this is a high current area, so I arranged many vias in rows. Similarly, for capacitive coupling like this, you should also place several more vias. Don't be reluctant to add vias. Areas like these are the same. Vias are arranged in rows to effectively improve the conductivity of the ground plane. Alright, that's all for today's comprehensive content. If you thoroughly enjoyed this video, please consider subscribing to my channel for even more engaging and informative videos. Thank you very much everyone for watching.